Hello, my name is Mradul Jain, Assistant Professor in Ajay Kumar Garg Engineering College. Today we will discuss the lattice, its definition, properties, bounded lattice and sublattice. So let's start from the lattice. Its journey start from the poset, and we know a set is called poset if it is reflexive, antisymmetric and transitive. Then for this poset we can draw the hash diagram. And for this hash diagram, we have to find out that the particular structure will be the lattice or not. So the lattice means a partially ordered set is said to be a lattice for every two element in the set L has unique least upper bound and the, or we can say the supremum, or a unique greatest lower bound GLB, or the we can say the infimum. So for the lattice we have to find out the LUB and GLB for each and every set of elements, every two elements set of elements. So we have to find out, and these two elements are called the LUB and GLB, least upper bound and greatest lower bound. So on the basic nature of the elements we can find out in a different if we have different type of elements are available, then we can find the LUB and GLB in different way. Suppose we have a structure and where we can see the different type of elements, where we can compare the elements. So and we know that in hash diagram each and every element is comparable with other elements. So if the two elements are comparable, then we can find the maximum and minimum elements. And in the hash diagram we also know that if two elements are comparable, then and it is the label diagram. If a element is written in lower label, then it is and the upper element will be called as the upper element of this particular structure. So we in hash diagram we can compare two elements, and you can see the always the label of these two elements will be different. One at the lower level and one at the upper level. So we can find on the basic nature of the elements. Suppose these two elements are comparable and there exists a relation between elements is less than and equal to, then we can find the maximum and minimum for the LUB and GLB. If the elements are written or the hash diagram has been made on the basic of divisibility, so then we can find out the LCM for the LUB and GCD for the GLB. If the two elements, because I am saying that we have to find the LUB and GLB for each and every pair, so it is very necessary. If sometimes the elements are related to each other, you can see in the diagram that two elements are related to each other. Sometimes you will see the elements are not related to each other. The two elements are not connected with each other. In such a way we have to, and in the lattice we have to find out the LUB and GLB for each and every pair of elements. So sometimes we will use the join and meet. So whenever we will use the join and meet, we will I will say you and I will tell you that if we are going upwards, then we will find the joining point. If we will going the downward, then we will see the meeting point. If the elements are available in the Boolean form 0 or 1, then we can find out the and or operation. If the elements are available in the set form, then we can find out the LUB and GLB with the help of union and intersection. And this LUB and GLB is also known as the supremum or infimum, and supremum, or we can say the supremum of A comma B or the SUP of A comma B. For the LUB or for the GLB, we can find the infimum of A comma B or INF of A comma B. So let's see the example. Suppose this is a structure, this is the poset, or this is the hash diagram for four elements A, B, C and D, and we can see that the A element is at the least level and D at the most upper level. And whenever we are comparing two elements, we can find out that the level of two elements are different. So if the level are different, or we can say there exists a relation between less than and equal to. So if we are comparing suppose two elements, and or we have to check the LUB and GLB for each and every two elements. So this is the best way to create a table. where you can find out each and every pair. Suppose we have to find out the LUV. LUV. So LUV will be the, that means the upper bound. LUV means least upper bound, and the LUV will be the least upper bound. So suppose we are comparing two elements A and A. Then you can see if we are comparing A comma A, that means there will be no the same element will be the least element and the same element will be the upper element. So for the A or A, it is the same. So the LUV will be A. If we are comparing A comma B, in this figure you can see A and B, and we are saying the LUV is the maximum between two elements. So in the A or B, B will be the maximum. So we will consider the LUV for A comma B, the B will be the maximum. So B is the LUV for A comma B. Similarly for A comma B, similarly for A comma C, if we are comparing A and C, the level of C is upper, so C will be the LUV. For A and D, when we are comparing A and D, then D is at the upper level, or D is the maximum, so we can say D will be the LUV. Similarly for B comma A, it will be B, B comma B, it will be B, B comma C, it will be C, and B comma D, it will be D. And similarly we can fill all the entry of this table. Similarly, if we have to find out the GLB, then we have to find out the minimum value between two elements. So suppose we are comparing A and A comma A, then again we are comparing, if we are comparing with the same element, then it is not required to find out the maximum and minimum. It will be the same. The maximum will be the A, because we are comparing with the same element. So A is the maximum and A will be the minimum. Similarly, for if we are comparing with the A comma A, that means the A will be the minimum. But if we are comparing A comma B, then A will be the minimum. So you can see in the table, if we are comparing A comma B, A is the minimum. A comma C, A is minimum. A comma D, A is minimum. Similarly, for when you compare B comma A, B comma B, B comma C, B comma D, and you can fill out all the entries. And it is very much required all the entry in this table, because you have to find out, if you have to check that this particular structure will be the lattice or not, you have to find out the LUV and GLV for each and every pair. So all the entries in this table must be must belongs to this poset structure. All the entries must exist, and it will be the part of this poset. Okay, if all the entries in this table, or we can say there exist the LUV and GLV for each and every pair of elements for this poset, then we can say this structure will be the lattice. Next example is, suppose this is a structure and we have to find out that this particular poset will be the lattice or not. So again I am saying that we have to find out the LUV and GLV for each and every pair. So what we will do, again we will create a table for each and every element mentioned in the diagram. So there are 7 elements A, B, C, D, E, F and G. So we will write all the elements in the column and all the elements in the row. Then we find out the maximum and minimum for each and every pair. So because if we are creating the table, then there exists each and every pair. So we will write the maximum or the minimum. For the maximum we are saying the LUV, or for the minimum we are saying the GLV. Okay, so in the structure, from this structure you can find, whenever you will compare two elements, the label of these two elements will be different, so you can find the maximum and minimum. Suppose we are saying between these two elements, again we are saying this A and B. So A and B, so you can see B is, the level of B is upper level, B is at the upper level, or B is maximum between A and B. So we will fill the entry by B. The most important thing is, because if the elements are in a straight line, then always you can compare these two elements and there exists the LUB and GLB. The main important thing is when the elements are not related to each other, then still you have to check there exists the LUB or GLB between these two elements or not. So important thing is कि suppose in this structure you can see this is a B and this is a C. Both are at the looking at the same level. So at this time you cannot see that B will be the maximum or the C is the maximum. In such a way, if this type of condition will exist, you have to find out, you will use the concept of joining and meeting point. So suppose we have to find out the LUV, then we find out the joining point where these two elements will join. So we can see from the diagram that B and C will join at D. So D will be the LUB. D will be the LUB. Suppose for the B and C, you can see B and C, this D is the meeting point. So D will be the LUB. Similarly for B and C, what will be the GLB? So we will find out the meeting point. So meeting point we can find out meeting point when we will going downwards. So when we will going downward, it will meet at A. So A will be the LUB. Sorry, GLB. A will be the GLB. So in such a way we can find out the LUB and GLB for each and every pair. So in the same diagram you can see for F and G, again these two elements are not related to each other, but we have to find out the LUB and GLB. So if we are find out the GLB, then you can see E is the GLB because this is the meeting point. But when we are going upward, there is no element exist at joining point. So we can say the LUB for F and G does not exist because when we are going upward for F and G, there is no joining point. So we can say there does not exist the LUB for F and G. So F and G, for the F and G pair, these two entries are blank. Similarly, we can find out the GLB for each and every pair. So for all the elements there exists the GLB from the table, it is very clear. So if because in the table we can see these two entries does not exist. So my definition says for each and every pair must exist the LUB and GLB. If there does not exist, even for single pair it does not exist the LUB or the GLB, then this particular structure will be the lattice. So it will be not the lattice because there does not exist any joining point or the LUB for F and G. So this structure will be, this is the poset, but it will not be the lattice. Again we can check if the elements are available in the form of set elements, and this is the set of all subset, this is the power set, and this is the poset for the power set. And again we will find out the LUB and GLB, and again I will tell you this is the union will be the LUB and intersection will be the GLB. So from the diagram we can use for LUB we can use the union, and for GLB we can use the intersection. So I have already told you in the first slide that on the basic nature of the elements we can find out the LUB and GLB. So in such a way, if the elements are available in the form of set elements, then we can find out the LUB and GLB with the help of union and intersection. So again we will write all the elements in the column and row. Then we will find out, and we will compare the two elements, and we will take the union. Suppose I am talking about if we will take the union of phi and phi, it will be a null set. Again you will take a union between phi and A, it will be A. Phi and B, it will be B. Phi and C, it will be C. Phi and A comma B, it will be A comma B. So you can easily fill all the entries of this particular poset. And again with the help of intersection, you can take the intersection between two elements, you can fill all the entries of this table. So from this table it is very much clear that all the entries belongs to this particular set. If all the entries you have filled all the entries in the table and it belongs to this particular table, then we can say this structure will be the lattice. Again we check we are considering another example, and you can see this is the set, and this has been made on the condition or the relation with the help of divisibility, because it is very clear that 1 can divide 2, 2 can divide 4, 2 can divide 12, 4 can divide 12, 1 can divide 3, 3 can divide 6, and 6 can divide 12. So each and every pair is dividing, each lower element is dividing the upper element. Whenever you are comparing two elements, the lower element is dividing the upper elements. So again we will create a table, and with the help of LCM and GCD, if the set has been made on the relation of divisibility, then we can use the LCM for LUV and GCD for the GLV. We can calculate GCD. So in the there are 6 elements, 1 2 3 4 5 6, 1 2 3 4 6 and 12, and these 1 2 3 4 6 and 12 we have written in the column and the row. So we have to find out the LCM. LCM between 1 and 1 will be the 1, 1 and 2 will be the 2, 1 and 3 will be the 3, 1 and 4 will be the 4, 1 and 6 will be the 6, 1 and 12 will be the 12. Similarly, we can find we can calculate all the entries, and similarly for the GLV we will calculate the GCD for each and every pair of elements. For the 1 or 1, the GCD will be 1. For 1 and 2, the GCD will be 1. For 1 and 3, GCD will be 1. For 1 and 4, GCD will be 1. For 1 and 6, it will be 1. For 1 and 12, it will be 1. For 2 and 1, it will be 1. For 2 and 2, it will be 2. So we can find out the GCD for each and every pair, and we can fill out all the entries in this table. If all the entries belongs to this particular set, then we can say this structure will be the set, because there exists GLV and LUV for each and every pair. So we can say this structure will be the lattice. Again we have to check that these particular structure will be the lattice or not. So I have already told you, and I have already made the table for this structure, and it will be the lattice. Again this will not be the lattice, because there does not exist the joining point for F and G going upward. When we have to find out the LUV when we are going upward, then we have to find out the LUV, or we can say the joining point when we are going upward. For F and G, the joining point does not exist, so this structure will not be the lattice. Again this structure will be the lattice, because there exists the LUV and GLV for each and every pair. Because suppose these two elements are not related to each other, but it will meet at E, and it will join at E and meet at A. So there exists for each and every pair of elements. So this will be the lattice. This structure I have already told you, if the elements are in a straight line or in a same path, then there always exist the LUV and GLV. So but mainly we have to focus when the elements are not related to each other. So in such a case when B and C are not related to each other, we will find out the joining point. Joining point is E, and for the B and C the meeting point is A. Similarly for C and D, the joining point will be the E, and C and D the meeting point will be the A. Again for B and D, the joining point will be the E, and for the meeting point for B and D, it will be the A. So again there exists the LUV and GLV for each and every pair of elements. So this will be the lattice, and it is very much clear that for B and C, there the joining point is D and the meeting point is A. So it will be the lattice. In this structure there is one more important concept, because if there exists a LUV and GLV, and it must be, I have already told you in the definition, it must be unique. There must exist for one pair of element, there must exist only single LUV and single GLV. In such a case for C and D, you can easily see that for C and D this is the meeting point when we are going downward, and A is another element when we are going downward. We are getting two meeting points. So I have already told you two meeting points cannot exist, two meeting point or two joining points should not be exist in the lattice. So this structure will not be the lattice. Again, see that this structure. So again, in this structure you can see for A and B there are two joining points. They are joining at C and these 2 points are joining at I. So again, if there exist two joining points, then this structure will not be the lattice. In the same way, you can see this structure for B and C. E is the joining point and B and C also joining at D. So there exists two joining point for B and C. So again, it will not be the, because there exist two joining points, so it will not be the lattice. So this structure will not be the lattice. And these are the lattice property, commutative property, associative law and absorption law. It is very much important, you should know and you should remember this particular concept, that if there exists any lattice, it will always follow these three laws: commutative, associative and absorption. If it is a lattice, then automatically it is bound that it is following the commutative law, associative law and absorption law. Next thing is the duality. In the if you have to find out the duality, just you have to change the LUV into the GLB and GLB to the LUV, or we can say these two, we are using the two operators. This is like AND or this is like OR. So we will change these two operators in AND, in OR in AND. So if there exists any identity or any lattice, so just you have to, if you have to find the dual, you have to change the LUV in GLB and GLB to LUV. Then if this structure exists, if this is a lattice, then its dual will also be a lattice. Then its dual will also be a lattice, and it will be the same. If this is the identity, the left hand side will be the right hand side. What is the bounded lattice? If there is two elements, one is greatest element is 1 and the least element is 0. So we have to compare, whenever we have to, sometimes we need to compare each and every element with 1 and 0. So we can use the logical AND and logical OR, because these are the two Boolean values 1 and 0. So in the power set we have seen that there exists a phi element, this is the least element, and there was the ABC, this was the top element having all the elements. So these two elements will be the least element and the greatest element. Okay, so whenever we are comparing with any element of these bounded lattice, so it will be always be the 1 and 0. So there always be exist these properties. If A or 1, it is always be the 1, because we know if OR operation says if any input is present, the output will be the 1. So A or 1 always be the 1. A and 1 it is dependent on A. If A will be the 1, then output will be the 1. If A is 0, output will be the 0. Again A or 0, again dependent on A. If A will be the 0, output will be the 0. If A is 1, output will be 1. If A or 0, then output always will be 0, because there exists a 1 0. There exists a single 0, then output will always be a 0 in case of OR operation. In the sub-lattice, we know in the lattice, if there exists a LUV and GLV for each and every pair of element, it is called lattice. Then suppose we are considering a particular part of this lattice and still exist a LUV and GLV for each and every pair, then we can say this is the sub-lattice of the given lattice. For example, suppose this is the poset for the D30, and what is the D30? We will consider all the elements which can divide 30 starting from 1. So 1, 2, 3, 5, 6, 10 and 15 and 13, these elements from 1 to 30 can divide 30. So we will consider these elements, and for these elements we can create a poset. So it is the poset for this particular D30 relation. In this poset you can see the 1, 2, 3 and 6. 1, 2, 3 and 6. If you will see and you will create a table for 1, 2, 3 and 6, and you can find then there exists the LUV and GLV for each and every pair. So we can say this particular structure is a sublattice of the D30. Again, suppose we are considering a structure 1, 2, 10 and 30. This is a straight line, because all the elements that can divide 30, 1 can divide 30, 2 can divide 30, 2 can divide 10, 10 can divide 30. So it is, and you will find out the LUV and GLV. Then again there exists a LUV and GLV for each and every pair. Similarly, different type of example are given here, and for each and every example is the sublattice of the D30 structure. So if a particular substructure of a given structure or a given lattice, still there exists the LUV and GLV for each and every pair. So we can say this is the sublattice for the given lattice. So in the whole lecture, what we have learned, that what is the lattice? We should know that the lattice, a structure is called lattice if there exists a LUV and GLV for each and every pair. Either it is comparable or not comparable, but there should exist the LUV and GLV for each and every pair. Next, we have learned the different type of lattices, different type of properties. So I have already told you in the second slide that if there exists a lattice, it should follow a commutative law, associative law and absorption law. And in the duality, we have if we have to find out the duality, we have to change the LUV and GLV, and GLV to LUV, we can find out the dual of the lattice. Then we have find out the bounded lattice. If there exists a top element, greatest element or the least element as 1 or 0, then this particular lattice will be known as the bounded lattice. Then in the sublattice, if we will consider a particular substructure of a given lattice and still this is a lattice, or we can say there exists a LUV and GLV for this particular substructure of this particular lattice, then it will be the sublattice. So these are the outcome of this structure. Okay, thank you.